Okay, so you want to own a data center, and I get it, because in your head, it's the cleanest business on earth. No inventory rotting on a shelf. No customers walking in with complaints. No employees calling in sick on a Friday. Just a big, quiet, air-conditioned building humming softly in the dark, full of blinking lights, and somewhere in there, money is being made while you sleep. You picture it like a modern gold mine, except instead of gold, you're mining attention, data, cloud storage, the entire digital nervous system of the world. Every email, every video, every photo of somebody's lunch has to live somewhere. And you want to own the somewhere. You want to own the internet's basement. That's the picture. A building full of servers, a fat contract with some tech giant, and rent that arrives every month like clockwork. Passive income at the scale of a small nation. What could possibly go wrong? Here's what the glossy investor deck doesn't show you. It doesn't show you the electricity bill that can run into the millions of dollars a month for a single large facility. It doesn't show you that the building itself, the concrete, the steel, the land, is almost the cheapest part of the whole operation. It doesn't show you the cooling system that, if it fails for even a few minutes, can cook tens of millions of dollars of equipment into scrap. And it definitely doesn't show you the thing that keeps data center owners awake at night, which isn't that nobody's using their building. It's the exact opposite. It's the terrifying possibility that everybody stops needing it all at once, because the entire industry decided to move somewhere newer, faster, and 40 miles closer to a cheaper river of power. So let's actually take the fantasy apart, piece by piece, and rebuild it into the real thing. Because a data center is not what you think it is, and by the end of this, you're going to look at those quiet gray buildings off the side of the highway completely differently. Quick note before we go. This is an explanation of how the business actually works and where its money and its risk live. It's analysis, not financial advice. Nobody here is telling you to go buy a warehouse full of servers. Let's start with the part everyone underestimates. The cost of entry. When people imagine building a data center, they imagine construction costs. Land, walls, a roof, some raised flooring. And sure, that's real money. But in this business, the building is almost an afterthought. The real number that matters is measured in a unit you probably never think about, the megawatt. Not square feet, not acres, power capacity. Because a data center is, at its core, a machine for turning electricity into computation and then getting rid of the heat that process creates. Everything about the economics flows from power. And building that power capacity is brutally expensive. Industry figures for a large, purpose-built facility land somewhere in the range of $7 to $12 million per megawatt of capacity. All in. And that's not the building, that's the electrical infrastructure, the backup generators, the cooling plant, the fire suppression, the redundant everything. A serious hyperscale campus might be built out to hundreds of megawatts. Do that math, and you're staring at a project that runs into the billions of dollars before a single customer plugs in a single server. This is not a business you fall into. This is a business you finance the way you'd finance a bridge or a power plant, because in a very real sense, that's closer to what it is. And here's the first crack in the fantasy. You imagined owning the servers, the blinking lights, the racks, the actual computers. But in an enormous share of this industry, the owner doesn't own the computers at all. The tenant does. You own the shell, you own the power, you own the cooling, you own the concrete and the steel and the extremely expensive plumbing that keeps the whole thing from melting. And your tenant, often some cloud company or enterprise you'd instantly recognize, rolls in their own hardware, their own secrets, their own liability. You are, in the most literal sense, a landlord for machines. Which brings us to the reframe, the one sentence this entire video hangs on. Write it down, because once you see it, you can't unsee it. A data center is not a technology business. It's a power and real estate business wearing a technology costume. Say it again, slowly. It's not about the computers. It's about electricity and floor space and cooling, sold by the kilowatt and the square foot on long contracts to tenants who need somewhere their machines can run 24 hours a day without ever going dark. The technology inside is the tenant's problem. Your problem and your product is a reliable, powered, cooled, secured environment. That's the whole thing. Strip away the mystique of the cloud, and what you're actually selling is the same thing a shopping mall sells or an office tower sells. Space, plus utilities, plus a promise that the lights stay on. The difference is that your tenants will pay a staggering premium for that promise, because when their machines go dark, their business goes dark, and they lose money by the second. That premium is the whole game, and it's why the numbers can look so seductive at first glance. But hold that thought, because the premium comes with a leash, and that leash is the reason this business quietly terrifies the people inside it. Now, here's where it gets interesting, and here's where most people's mental model of passive income completely falls apart. Because you might think, fine, I built the shell, I signed a tenant, now I sit back and collect rent like any landlord. Except a data center isn't like a strip mall where you flip the breaker and walk away. A data center is a living organism that has to be fed continuously. With power, with cool air, with maintenance, with human attention. Or it dies within minutes. Not months. Minutes. Think about what's actually happening inside that quiet gray box. Thousands of servers, each one a small furnace, all packed together, all running flat out, all generating heat. A single dense rack of modern equipment can throw off as much heat as a couple of space heaters running constantly, and you've got hundreds or thousands of racks. Left alone, the room wouldn't just get warm. It would climb toward oven temperatures fast enough that the equipment would start throttling, then failing, then frying in a matter of minutes. So the cooling never stops, ever. And the cooling itself is one of your single biggest ongoing costs, sometimes rivaling the cost of the power feeding the computers in the first place. That's the strange part nobody tells you about the internet's basement. Roughly speaking, for every unit of electricity a data center spends running its actual computers, an older, less efficient facility might spend nearly another full unit just moving heat out of the building. The efficient ones have squeezed that overhead way down. The bad ones bleed money into the air conditioning. And that single ratio, how much power you waste keeping the room cold versus how much you spend on the actual work, is one of the quiet numbers that separates the data centers that make money from the ones that slowly, invisibly lose it. So let's put a name to that number, because the people inside this business live and die by it. They call it PUE, Power Usage Effectiveness. It's a simple ratio, total power coming into the building, divided by the power actually reaching the computers. A perfect score is 1.0, meaning every watt goes to the machines and nothing is wasted on cooling or lighting or losses in the wiring. Nobody hits 1.0. The best hyperscale facilities in the world get down near 1.1 or 1.2. A tired old server room jammed into a converted office might run 2.0, meaning it burns a full watt on overhead for every watt of real work. And here's what that actually means in dollars. If your electricity bill is running into the millions a year, and it will be, then the difference between a 1.2 and a 1.8 isn't a rounding error. It's the difference between a profitable building and a bleeding one. Same tenants, same rent, same servers, just a smarter box around them. That's the entire logic in one sentence. In this business, you don't win by charging more, you win by wasting less. And this is where the fantasy of the passive landlord really comes apart in your hands. Because to waste less, you have to spend more up front, a lot more, on the parts nobody ever photographs. You've seen the glamour shots. Rows of blinking servers, blue LEDs, glass walls, a technician walking a spotless white floor. That's the marketing. What the marketing doesn't show you is the mechanical yard out back, and that mechanical yard is where the real money went. Walk out there with me for a second. You'll hear it before you see it. A low, constant industrial roar, the sound of enormous chillers cycling water through the building like blood through a body. There are pumps the size of small cars. There are cooling towers venting warm mist into the sky. Day and night, in January and July, it never stops. There are miles of pipe. And then there's the electrical side, which is honestly the part that keeps operators up at night. Because a data center's promise, the whole reason your tenant pays that staggering premium, is that the power never ever goes out. Not for a second. Not for a flicker. And the public grid, for all its reliability, was never built to make that promise. So you build the promise yourself, redundantly. obsessively. Here's how it works. The city power comes in, and the moment it wavers, and it does waver more often than you'd think, the load has to keep flowing without a hiccup. So the servers are actually running through banks of batteries at all times, an uninterruptible power supply that can carry the entire building for a few minutes on stored charge alone. A few minutes. That doesn't sound like much, and it isn't meant to be. It's a bridge. Those few minutes exist for one reason: to keep everything alive long enough for the diesel generators to wake up. And the generators are a sight. We're talking about machines the size of shipping containers, sometimes a whole row of them, capable of powering a small town, sitting there fueled and idle, waiting. They get tested constantly, fired up, run under load, checked, logged, because a backup generator that fails on the one day you need it isn't a backup at all. It's a very expensive decoration. When the grid drops, those UPS batteries carry the load for the 10, 15, 30 seconds it takes the diesels to roar to life and sync up, and then the whole facility runs on diesel until the city power comes back. The tenant, meanwhile, notices nothing. Their machines never blinked. That seamlessness, that absolute invisible continuity, is the product. And you paid for it twice. Once for the primary system, and again for the backup that mostly just sits there. That's the reframe most people miss. You are not really being paid to house computers. You are being paid to guarantee that a certain flow of electricity and a certain volume of cold air will never ever be interrupted, and to prove, on paper, in a contract, that you can do it. The servers are almost incidental. What you're really selling is certainty. And certainty, it turns out, is the most expensive thing in the world to manufacture, because to sell, it will never fail. You have to build a machine that assumes everything will. So let's total up what you've actually bought, because the number is where the daydream goes quiet. The shell, the concrete, the roof, the security. That's the cheap part, believe it or not. The expensive part is everything you can't see. Industry people talk about the cost of building capacity in terms of dollars per watt of power the facility can deliver, and depending on how much redundancy you're buying, that figure has run somewhere in the range of $7 to $12 per watt of usable capacity, sometimes more for the highest reliability designs. Stack that up. A facility rated to deliver tens of megawatts, a mid-sized building by modern standards, can run into the hundreds of millions of dollars before a single customer server ever powers on. The very large campuses being built now cross into the billions. That's not a typo, and this is analysis of how the business works, not a suggestion to go price one out. $1 billion, poured mostly into cooling plants, electrical gear, and backup systems that exist to handle a disaster that might never come. And here's the part that quietly terrifies the people who actually own these things. All of that capital, all of it, is a bet on demand you signed up for years before you knew whether the demand would show up. Because a data center isn't a strip mall you can lease out one storefront at a time as tenants wander in. The power, the cooling, the redundancy, a huge chunk of it has to exist on day one, fully built, whether the building is 1% full or 90% full. You've committed the money. Now you need to fill the room. And filling the room is its own strange, brutal business, because the way a data center actually makes money is not the way you'd guess. And the difference between the two models is the difference between a comfortable, boring, decades-long return and losing the entire thing to a technology shift you didn't see coming. Which brings us to the question that decides everything. Who, exactly, is signing the lease? And what exactly are they paying you for? Because there are really two businesses hiding inside the same building, and they behave almost nothing alike. The first is what people in the trade call co-location, colo for short. You build the room, you sell space in it by the rack and by the kilowatt, and 100 different customers rent a little slice each. A bank puts its servers here, a hospital network there, a video game company in the corner. You're a landlord with excellent air conditioning, and your income arrives the way rent does, in a wide, diversified drizzle from many tenants, none of whom can hurt you badly if they leave. That diversification is the whole safety of the model. Lose one customer, and you barely feel it. Fill the room to 80–90% utilization, keep the power flowing, and you throw off a steady, unglamorous cash flow for a very long time. The second business is the one everyone's building for right now, and it's a completely different animal. It's the hyperscale lease. Here, you don't rent to 100 small tenants. You rent the entire building, sometimes the entire campus, to a single giant. One of a handful of cloud and technology companies on Earth signs a lease that runs 10–15 years, and they take all of it. And here's the strange part. That sounds like the safest deal in the world. One tenant, enormous, creditworthy, locked in for over a decade. But you've just done the exact opposite of what made the first business safe. You've concentrated everything. Your entire building, your entire hundreds of millions in capital, now depends on the continued goodwill and the continued technology strategy of one customer. That's the entire logic in one sentence. Co-location spreads the risk across a crowd, and hyperscale trades that safety for scale and a signature. Both can print money, they just die in completely different ways. And the way the money actually moves is where it stops feeling like real estate at all. Look closely at a data center lease and you'll notice something odd. The rent isn't really rent. A big share of what the tenant pays is tied to power. You commit to delivering a certain number of megawatts, and they pay for that committed capacity whether they use every watt of it or not. Then, layered on top, they pay for the electricity they actually draw, often passed straight through at cost. So a chunk of your revenue behaves less like a landlord collecting rent and more like a utility selling a reservation. You're not selling square feet. You're selling the guaranteed right to power and the guaranteed right to keep that power cold. The building is just the packaging around the two things that actually matter, which is why the survival math here is so unforgiving and so specific. In most buildings, the number that decides your fate is occupancy, how much of the space is rented. In a data center, the number is different. It's the gap between how much power you're paying to have available and how much power is actually generating revenue. The industry has a whole vocabulary for how efficiently you turn purchased electricity into useful computing, and every fraction of waste, every watt spent on cooling that didn't have to be, comes straight out of your margin because in some facilities the power bill rivals or exceeds every other operating cost combined. You can have a full building and still bleed if your machine is inefficient. And you can have a half-empty building and drown because remember, you built for the whole thing on day one. Every empty megawatt is capital sitting in the dark, paying interest, earning nothing. That's the quiet killer. Not vacancy alone, stranded capacity, power you spent a fortune to make available that no one is paying you for. Now, the structural risk, the way this business genuinely dies, not the way a nervous first-timer imagines it. It isn't a fire, it isn't a hacker, it's obsolescence. And it arrives faster here than almost anywhere else you can put a large amount of money. Think about what happened in the industry over the last stretch of years. Buildings were designed around one assumption about how much power a single rack of equipment would ever need, a modest, predictable number. Then the demand for heavy computing changed. The machines got vastly more power-hungry per square foot, and suddenly a building engineered for the old world couldn't physically cool the new one. The concrete was fine. The location was fine. The design was a decade behind. Owners who had poured hundreds of millions into a facility discovered that the thing they'd built to last 30 years was functionally outdated in a fraction of that, not because it broke, but because the world's appetite outgrew it. That's the failure mode. Not collapse, irrelevance, a perfectly good machine that the market quietly walked past. And this is where the two businesses split one last time. The colocation landlord, with a crowd of smaller tenants, can retrofit slowly, upgrade a hall at a time, evolve. The owner who bet everything on one hyperscale lease is far more exposed. If that single giant decides in the next cycle that its computing strategy has moved somewhere else, or to hardware your building can't feed, you don't lose a tenant. You lose your reason to exist. The lease protects you for its term. It does not protect you from the day it ends. So walk back out of the daydream for a second, into that endless dark hall of blinking lights and roaring cold. What did you actually buy? Not a building, not even the servers, Those belong to someone else. You bought an obligation to keep power flowing and air cold forever, without interruption, in a world where the definition of enough keeps moving underneath you. You bought certainty as a product, knowing certainty is the one thing that decays the moment it's built. The winners aren't the ones with the most concrete or the flashiest campus. They're the ones who understood that a data center isn't a real estate asset at all. It's a utility wearing a warehouse's clothes, and its true lifespan is measured not in the strength of its walls, but in how long the world's hunger keeps pace with what it was designed to feed. Build for certainty and stay humble about how briefly certainty lasts. So here's what I want to know from you. If you had the capital and the choice, which machine would you rather own? The crowded co-location building with 100 small tenants and 100 small risks, or the single hyperscale lease with one giant name on the contract and everything riding on it? Tell me which risk you'd rather sleep next to, and why. I'll read every answer.